and let us share the screen. Share screen, sphere. Can you all, have you all got that? Can you see the textbook? Sir. Okay. Right. Let us pick on, who should we pick on? Bianca, choose somebody for me to pick on. Okay, Brogan has chosen. Okay, who must I pick on? Morgan. Ma'am has chosen you to be picked on, Morgan. So get that mic on.
Morgan ran away.
Morgan, have you run away? She's run away. All right. Okay, I'll just start it off myself, and then I'll pick somebody. So it says we're doing exercise 3, finding mean and standard deviation of normal distribution. So it says veterinary studies show that the resting heart rates of a large breed of dog are normally distributed with a standard deviation of 29. Can we have quiet in the background, please? Of 29 beats per minute. A rare disease called sinus tachycardia, or otherwise,
Sir,
as we in the veterinary profession, yeah.
Can you hear me now?
Yes, I can hear you now, Morgan.
Sorry, my mic wasn't working on my computer.
No, that's okay. That's okay. Right. So you've been chosen, Morgan. So a rare disease called sinus tachycardia, otherwise known as ST for us in the veterinary profession, is likely to occur when a dog's resting heart rate exceeds 140 beats per minute. ST is known to be prevalent in only 2% of this population of dogs. Determine the mean resting heart rate. Now, there was a time in your life when a question like that would scare the crap out of you, but now you're going to be fine. Right. So, Morgan, any normal distribution question? If you don't know what you're doing, what do you start with?
A diagram.
The diagram. So if we go and draw the diagram, we have what? Okay, and we're looking at heartbeats of a dog. Who would have thought? Heartbeats. Okay, and that's our X score over there. And we're going to have our Z scores. And what do they give us? They tell us sigma is 29 beats per minute. And blah, 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 blah. And they tell us the dog's resting heart rate is likely to, shame, these dogs have got a hectic rate, at 140 beats per minute. Okay, then the area to the right of that is because its prevalence is only, so the excess heart rate, if the heart rate exceeds 140 beats per minute. So if it says over here, if it exceeds 140 beats, so if it's bigger than 140 beats per minute, then that affects only 2% of this type of dog. All right. So this area over here is 2%, which is 0.02. Morgan, does that make sense?
Yes.
Okay, 2% of dogs have a heart rate greater than 140. And do they tell us the mean? No. The question is go find this mean. Okay. That Z score there is 0. So in order to find the mean, I'm going to ultimately end up using Z is equal to X minus mu over sigma, right? And I know sigma, and I've got an X score, and I've got a mean. I mean, I'm looking for a mean. So what I have to find in order to calculate the missing variable I've got is Z. Okay, so I'm going to have to find the Z score, okay, that goes with that X score. Okay. So, Morgan, on the table, am I going to look up 0.02?
No, you're going to look up
No, you're
0.5 minus 0.02.
Well done, Morgan. Okay, so that is going to be 0.5 minus 0.02, which is going to be 0.498. Okay, so, and that is an area, right? So on the table, oh, shingas mazoo, I need a table of Z scores. Sorry. Amber, did you steal my Z scores? Aha. There they are. Okay. So, Morgan, let's have a look. An area of North. Have I done something wrong?
Isn't it 0.48?
It's 0.48, Morgan. I'm sorry. Is that what you're going to say?
Yes.
I do apologize. Okay. So Morgan, let's go try find 0.48. 0.48. Where are you hiding?
It's 2,06, I think.
Well, this is 2 away, that's 3 away. Okay, so again, if you pick either one of those two, but ideally, I suppose we could go the middle, which would be what? 2 comma, that's 0.5, that's 0.6.
0.55.
So it's 2,055, eh?
Yeah.
Okay. So we're going to use 2,055. So that's the associated Z score is 2,055. So it's over 2 standard deviations, which seems about right. Okay, to the right. So now I can go, the question is, go find mu. So let's go. Z sigma minus x is equal to minus mu. So if I move it across, mu is going to be x minus z sigma. And x is 140.
140.
The z score is 2,055. And sigma over here was 29.
Your answer is 80.41.
It is 80.41. Lovely stuff. Okay, so who would have thought we'd find out today when you woke up, did you say you would be able to calculate the resting heart rate of a certain species of dog? No, you would not have guessed that, Morgan. And look, this is what AP does for you. Okay, 80.41 beats per minute. Okay, does that make sense?
Yes.
Morgan, would you like to nominate the next contender?
I can't see who's on here because it's on my phone now.
All right.
But Hannah's on. Hannah's on. I know Hannah's on.
Hannah, would you like to volunteer or would you like to pick somebody? Either or.
So I'm busy printing at the moment, so it's quite loud.
Okay. Right. We'll go with Caitlin. Caitlin, welcome. Are you still here?
Yes, sir.
Oh, shame, it's your turn. Right. Now we have a fascinating question about Emmenthal cheese.
Delicious Emmenthal.
And we're looking at the number of holes in Emmenthal cheese. Right, Brogan, this is why you should do AP Maths. Right, it says the number of holes in 100-gram servings of Emmenthal cheese is found to be normally distributed. Who would have thought? It is known that about 4% of servings have fewer than 176 holes. Who actually studied this will never know. And about 12% of servings have more than 216 holes. Find the mean and standard deviation for the amount of holes for 100-gram servings. Well. So, Caitlin, how do we start?
The diagram.
The diagram, standard answer. Good. Right, and X is going to be number of holes. Of, as we say in Afrikaans, die nommer van gatte. Number of holes in the cheese. Right. And they tell us what? There are two scenarios. The one is, the first one is it's known that about 4% of servings have fewer than 176 holes. Okay, sorry, so this bit over here. 4% of servings have fewer than 176 holes. So where's that going to be? Well, we only want 4% to the left of something. So 4% to the left of something must be quite far down here. So that is 4%. 4% is fewer. So that's 0,04. We were supposed to bring goodies to eat today. I think it was Husna. But she's not even here. Right, 4% is 0,04. And the X score that goes with that is 176 holes. Right. So that's our first bit of information we're given. 4% of these cheeses have less than 176 holes per 100 grams. Okay. Right, and the next bit of information we're told is that 12% of servings have more than 216 holes. So 12% be a bit more, will be about over here roughly. So this area over here is 12%, which is 0,12. So 12% have more than 216 holes. Okay. So what do we need? The question says, go find the mean and standard deviation. So we're looking for the mean and we're looking for the standard deviation. Okay. Right. So what am I going to need? I'm going to need two equations. Okay. In order to do that, I need two equations with the variable mu and sigma. Okay. So how can I get, I'm going to get one equation from this bit of information in green, and I'm going to get another equation from this information in yellow over here. And that's going to be the basis for my two equations. And in both cases, I'm going to be using z is equal to x minus mu over sigma. Okay. So I need those to stay there. At the moment, okay, all I've got is an x score. So what I'm going to have to go find is this z score that goes with this over here. Okay, so I'm going to need to find that z score, because once I've got those two, then I'm going to be left with sigma and mu. So that's going to give me one equation with sigma and mu. So, Caitlin, if we go to the green area, to figure out this z score, I'm going to have to use the area to the right of this. What's this area in yellow, in pink, going to be here?
0,5 minus 0,04.
Good. So that's 0,5 minus 0,04, which is equal to 0,496. Eh? What? 0, what? 9. What's that again? My brain.
0,46.
0,46. Okay. So that's 0,46. Right. Okay. So now I'm going to have to go to the table and I'm going to have to find an area of 0,46 and then find the associated z score. So let's try to do that. 0,46. Where are you hiding? Well, this is pretty close. This 0,4599 is essentially 0,46. So that goes with 1,75. Do you agree, Caitlin? 1,75. Okay. But it's to the left, don't forget, guys. So it's going to be a negative z score, and it's negative 1,75, we said, eh? Z is equal to negative 1,75. Okay. So I've got that score, z score is negative 1,75, right? So now that z score goes with that x score, so I can substitute them into the same equation, and I'm going to get negative 1,75 is equal to x is 176. Please stop me if I make a careless error. Minus mu over sigma. And we're going to have to solve simultaneously, so let's times out for now. Negative 1,75 sigma is equal to 176 minus mu. Let's leave it like that for now. Okay, and there's our first equation. Did you get that, Caitlin?
Yes.
Okay. Right. Mara Manekia. Have you gone, Mara?
Yes, sir.
Welcome back. Right. So, Mara, I need to get an equation here, right?
Yes.
Okay, and I'm going to use z is equal to x minus mu over sigma. So, Mara, what is, I'm going to look at this area here. What's that area going to be?
It's going to be 0,5 minus 0,12, which is equal to 0,38.
Oh, fantastic. Thank you, Myra. Okay, so this z score over here is 0,38. Right, so those two things go together. That z score, that's your x score, that's your z score. Yeah?
Isn't that the area?
Yes, it is. I was just checking if you're awake. Okay, well done, Myra. Okay, so we're looking up 0,38. Okay, thank you, Myra. All right, let's go find 0,38. And that's kind of, if you agree, Myra, it's in the middle of those two, eh?
Mm-hmm.
So what we're going to use?
1,175.
Exactly, that'll be 1,175. Thank you, Myra. Okay, So this z square over here that goes with this is z is equal to 1,175. Okay. Right. So now I'm going to go 1,175 is equal to 216 minus mu over sigma. So I've got 1,175 sigma is equal to 216 minus mu. Did you get that, Mara?
Yep.
Okay, right. Now, guys, I want you to get your calculators because in AP, like, you know, it's going to be, it's a big rush, right? So it's probably worth learning, I don't do this enough, to use your calculator to solve simultaneous equations. I mean, you can do it the normal way, isolate u, sub in, but if you think this is going to save you time, let's try it. I need to practice this a bit as well. So to solve a simultaneous equation in your calculator, we're going to go mode equation. Are you with me, Mara?
Yes, sir.
Okay, now the simultaneous one is that top one. A n x plus b n x y is equal to cn, right? But now just be careful. How it's arranged is telling you.
Sir,
Yeah.
sir, isn't it 1,075 instead of 1,75?
Let's have a look. No,
Is it
because here's 1,1, isn't it? And somebody
Yeah.
else?
I think that's right.
Morgan? Did you get 1,175 or anyone else is there?
I got 1,1, yeah, 175.
Okay.
You sure? Because look here, Mara,
Yeah.
there's 1,1. Okay, so it's in line with the 1,1. That's 1,17. That's 1,18. So that'll be 1,175.
Yeah.
Okay, cool. Right. So the calculator says this, guys, and you've got to decide whether it's worth your while to use it or not. But let me just show you. And you've got to arrange every equation in that order. Okay, so if we let our x's be sigma, okay, what the calculator calls x, let that be sigma, then it's saying to us on the left, we've got to have negative 1,75 sigma, right? Then we've got to have our other variable. So we're going to say plus mu, okay? This is the green equation over here. Okay, but I've got to rearrange it in the right order. Is equal to, and the constant is 176, right? So that's our equation 1. Our equation 2 is going to be, let's make it this red one, is going to be 1,175 sigma plus mu is equal to 216. In a case like this, it's probably quicker to do it without your calculator, but when you get really ugly ones where you can't just get rid of something, it might save you a bit of time. Right, so what do I do on my calculator now? Okay, I go and I press 1. Okay, and in my first, I enter the first equation, right? But it must be in this order here. Okay, in the same order. So I'm going to go negative 1.75 equals, this one's going to be 1 equals, and this one's going to be 176 equals. Right, enter the first equation. Mari, with me?
Yes, sir.
Okay, then this equation over here, I'm going to go 1.175 equals 1 equals and 216 equals, right? Now, when I press equals, what they call the solution for x is going to be our solution for sigma, right? So if I press equals, please work, I get mu, the sigma, because it says x on my screen, is equal to 1,600 over 117. Let's make it that. So 13,675. So mu is equal to 13,6. Let's make it 13,68. I mean sigma. Okay. Let's just check if we're right. What can we do? Yep, that is right. Okay, great. And then we press equals again. And then we get mu is equal to 199,93, which is, wait, how come this is a different answer to what they get? No, they made a careless mistake. The answer in the textbook is wrong. Genuinely it is, because that 13 is, I'm sure it is, 176. Okay, I think we must be right. If we got the one right, the other must be right as well. Okay. Did you guys get that same thing? Did anyone else try to do that on their calculator?
Yes, sir.
Yes, sir, I got the same.
Yeah.
Did you get the same thing? So I think that's a bit quicker. Okay. So the answer in the textbook is wrong, because they said 176 plus 1,75 times 13. Let me just see something. 176 times plus 1.75 times 13,7. Yeah, the textbook answer, yes, thank goodness, the textbook answer is wrong. They made a careless error. Okay, right. So that should be 199,93. So, as I say, in this case, it wouldn't have saved you much time because it's quite easy to isolate mu. But when you get equations like 2,16x plus 3,4y is equal to 17 or something like that, okay, and they've got a similar scenario in another equation, the work for that simultaneous equation is going to be a lot. And in AP, we're not going to give you marks for methods for solving simultaneous equations. Okay, so get used to this. The most important thing, though, is I always write, if I'm using my calculator, I literally write it down like this quickly first, so that you don't start mixing up, because if you put your sigmas there and if you swap those things around in any way, your calculator is not going to work. But I think it is worth practicing doing your simultaneous equations on your calculator, especially for core. Be careful of mark allocations to see if they've allocated marks for simultaneous, and certainly for any question where they say to you, solve this simultaneous equation or find a point of intersection in core, okay, you're going to have to show your steps. But this can save you a bit of time. We good?
Yes, sir.
Yes,
Okay.
sir.
Guys, I think I'm going to do, okay, let's do number 5. It's different, okay, so we should be able to sneak that in, and if we have time, we'll go back. And okay, right, so in question 5, okay, it says, okay, suppose that x is normally distributed sigma with mu and sigma squared, okay, and then it says to us, it's given in question A, given 5 sigma is equal to 3 times the mean. And the question says, find the probability that x is less than 2 mu. Okay. Right. So this is quite I'm a little bit nervous about doing this question. I might have to look at the memo, but let's try not. Okay. But we do need a sip of water and a sip of coffee. Mara, you're going to stay with us.
Okay.
I don't know who else is there. Okay. Sorry?
Okay.
All right. Unless there's anyone else who wants to volunteer. Amran, Brogan? No, they're not key. Sorry. Right. It's going to be you, Mara. So, what the hell I'm going to do to start off this thing over here, Mara, is quite a tricky question. But I would think, okay, we're going to have to look at this formula. Okay. So if I know that z is equal to
X minus mu over sigma.
Okay. And I'm looking at, I know we're not going to have to do it equal to, but if I'm looking at x is equal to, we're looking with x scores there, right? So let's look at it. If we have an x score of 2 mu, okay? Ultimately, what am I going to have to find? The question is go find a what? Find a probability, right? So the question is find a probability, which means I'm going to have to, in order to find a probability from my table, what do I need? I need a z-score, right? Okay, so in order to find a probability, I'm going to need a z-score. So how the hell am I going to get a z-score? Well, I'm going to have to use that formula, I think. Okay, and we know that x is equal to 2 mu. And we also know that 5 sigma is equal to 3 mu. So if x is equal to 2 mu, and I use this formula, Z is going to be equal to 2 mu minus mu over sigma. Okay. So Z is going to be equal to mu over sigma. Okay. But now I need to end up, in order to figure out a probability, my Z score has to be a constant, right? So how can I possibly turn my Z score into a constant? Any suggestions, anyone? Not just poor Myra. Anyone, feel free to shout out. How can at the moment, I've got this. I've got Z is equal to mu over sigma. I need Z to be just a number, a constant. What can I use to get to that scenario?
Can you not use
What else did they give me in the sum? Remember, they don't give you things just because for the hell of it. Okay, what else did they give us that we haven't used yet?
5 sigma is equal to 3 mu.
Thank you. So I've got 5 sigma is equal to 3 mu, which means I can eliminate, if I isolate one of the variables, we can either get rid of sigma, we can get rid of mu, whatever. Let's say sigma is equal to 3 mu over 5. Okay, so now if I sub that into that, okay, you're going to get rid of your constants, of your variables. So sorry, you're going to have Z is equal to mu over, I'll replace sigma with 3 mu over 5. And if I tip and times, I get Z is going to be equal to mu over 1 times 5 over 3 mu, which is going to be 5 over 3, which is what I wanted. Because in order to find a probability, I've got to get a Z score. But our table doesn't work with fractions, it works with decimals. So if I go 5 divided by 3, I'm going to get 2 decimal places, 1,67. Okay. Right, so now I've got a Z score. Now what probability am I, once I get a Z score, now I can kind of think about a diagram, okay? And I wanted to know, the question was, what's the probability that X is less than 2 mu, okay? But, which is going to be the same thing, because we worked out now that when X is 2 mu, those two things go together, right? When X is 2 mu, the associated Z score, okay, so when X is equal to 2 mu, the associated Z, it's quite a tough question. The associated Z score is 1,67. Mara, are you vaguely with me?
Yeah.
Okay, so by asking us, find the probability when X is less than 2 mu, it's the same question as find the probability that Z is less than 1,67. So that now becomes a question, which is manageable now. So now I've got to figure out what's the probability that Z is less than 1,67. So I'm going to draw my diagram. Okay. And 1,67 is to the, remember we're just looking at Z scores. So for Z scores, mu is 0, right? So 1,67 is to the right of that. Okay. I just want to check I'm on the right track here. What question are we doing, Mara? 5, eh?
Question 5A.
Yeah, I'm right. Okay. Amazing. Right. So 1,67 is somewhere to the right here. So here's 1,67. And I'm trying to find, just working with Z scores, so I'm trying to figure out that area over here. Okay, so I'm going to give you some time, everyone, quickly catch up, get down what we've got down over here, and then try and figure out, okay, what this area is going to be over here when you've got a Z score of 1,67. Go for it. I'm going to have some coffee. Right, Myra, what did you get for a z-score of 1,67?
0,4525.
Fantastic stuff. So that gives us this bit over here. So that's 0,4, what's it, 4,525. But the question wants the whole of the yellow region. That 0,525 is just between, it's just that region over there, right? Okay. So the total region, so the probability that x is going to be less than 2 mu, what do I have to do to that, Myra?
Add 0,5.
Oh, fantastic. So I'm going to get 0,4525 plus 0,5 is equal to 0,9525. Okay. That's going to be that area over there. Tough question. You got it?
Yes, sir.
Okay. Right. So let's, okay, we'll have time to, lesson ends at 11:50 or 11:55?
11:50.
50.
Okay. Well, let's call it a day then. Okay. So if you can, if you do get some time, try do question 2, 4, and 5B. Okay. But we're doing pretty well. Are you guys kind of getting the hang of this?
Kind of.
Yeah,
Okay. It
kind
takes a
of.
bit of time, guys. That is not straightforward. So be patient with yourselves. Okay. We'll keep working on it. Alrighty, guys.
Thank you, sir.
Bye-bye, everyone.
Thanks, sir.
Bye.
Have a good day. Arrivederci. We'll see you, some of you on Monday, hopefully.
Yes.
Yes.
Yeah.
Bye,
Okay.
sir.
Bye, guys.
Bye, sir.